Here's the problem statement. A heap can be used to optimize the comparison process. A heap is a data structure that allows efficient retrieval for the smallest largest element in the collection. In this case, a heap can use it to store and manage frequent count of character in the input file. Type of data structure. Objective. The objective of this project is to utilize the heap data structure to optimize the file comprehension process. Specifically, a heap can be used to store and efficiently manage the frequency count of character in a file. The primary goal is to encode character based on their frequency using the Huffman coding, a comprehension algorithm that assigns shorter binary code to more frequent character. Purpose of this code. In a mini heap, the smallest element, the character with the lowest frequency, is always at the root, allowing for the efficient travel during the encoding process. Project description. In file comprehension, one of the common algorithms used in Huffman coding. The process involves creating a binary tree based on frequency of character in the file. Using a heap, we can efficiently build this tree by repeatedly extracting the least frequent character and combining them into a new tree node. This approach results in optimized representation on file, reducing the overall file size. Key features: efficient character frequency management. The heap ensures that character frequency are accessed in the optimal order, the smallest first, for the building the Huffman tree. First retrieval of minimum frequency. The min heap allow time complexity for insertion and extraction process, which is crucial when the handling large file. Reducing file size. By using this code, we aim to reduce the number of bits used to store frequently occurring character, thus compressing the file. Real-time example. Imagine compressing a text file where the letter E occurs frequently and the letter Z is rare. A heap can quickly identify E as the most frequent and Z as the least frequent, ensuring that E get a shorter binary code than Z, optimizing storage. Graph representation. In the mini heap, each node stores a character and its frequency. As characters are combined, nodes represent its internal node of the Huffman tree, storing a cumulative frequency but no specific character. Example: heap input A, 5, B, 9, C, 12, D, 13, E, 16, F, 45. Heap output: a binary tree where each leaf node represents a character and internal node represents a combined frequency.
Here's the code explanation for the Huffman coding. Here the four including statement called header files. First, IOStream Q unordered map vector. Uh, with using namespace study, we can include various instructions to the computer like scanf, printf, and cout, like input output devices to control over from the using namespace study. Node structure for the Huffman tree. Struct node character C integer frequency node star left star at two parameters left right for the um, uh, star operators using node character integer frequency. Character is equal to character, is equal to frequency, left is equal to right, null ptr. Here comparison object for the priority queue min heap. Here is the structure to represent the min heap comparison object. Next, function to print Huffman codes. Here few functions to print Huffman codes and represent how the Huffman codes are implemented in the C program and in data structure. Void print code is used to print if not root, if the root is not is a root. Next, function to build the Huffman tree. Huffman tree is used to build a tree with the nodes. Create a leaf node for each character and add it to the priority queue. Min heap push while min heap size not equal to 1. Node star left is equal to min heap top function, node star right is equal to min heap top. Create a new internal node with a frequency equal to sum of two nodes frequencies. Node star merged is equal to new node left frequency plus right frequency. Merged left is equal to left, merged right is equal to right. Add the new node to the heap using min heap push function. The remaining node is the root of the Huffman tree and return min hub at top root node function to generate the Huffman codes. Here the functions are used to print or generate Huffman codes. Unordered map Huffman codes build Huffman tree using parameter frequency function to calculate frequency of character in the input text. Unordered map calculate frequencies. Unordered map frequency map. Return frequency map function to compress the input text using Huffman codes. String compress compress text plus equal to Huffman codes return compressed text. Here the main function to implement the structure of the program and give us the result. First we call string test. This is an example for Huffman encoding. Unordered map. Using unordered map function and we have to split the code into using Huffman codes. Generate Huffman codes, compress the input text. Output of the original test Huffman codes or for auto pair Huffman code cout pair dot first using pair first function. Cout compressed text return 0. Explanation of the code in shortly. We have node structure, priority queue, Huffman tree construction. Here the three main objects to implement the code. Node structure. This node structure contains multiple of data types like character, frequency, and pointers, and priority queue. This queue using min heap operation to traverse the text we have given and give the result as a Huffman codes. Huffman tree construction. Here the tree like binary tree and other trees, and this is called Huffman tree construction. Two nodes with the lowest frequency are repeatedly extracted, merged into a new node and reinstated into a heap. This continues until a single node remains, generating Huffman codes. This is the last and the main part of the program to generate and print the codes. The print code function traverses the Huffman and recursively assigning binary codes to each character based on the path. Let's talk about the output function. Output plain text we have given is this is example for Huffman coding. The Huffman codes. This gives each code for each letter in the original text and travels it through the queue using min heap function. That's all.